represent our project-based learning. So for the members, the first one is me, Perdana.
My name is Aidil Putra.
And my name is Saut and Pardede.
So our project is Organik dari Limbah, Gonggong dengan Kontrol Otomatis. In this presentation, we at least have 11 points that we want to explain. First one is background. That will be explained by Mr. Saut.
Alright, now I will explain about the background of the problem. Organic waste management in coastal area is a major challenge in Indonesia. And we focused on Lanche Island, where most of the residents are fishermen, shellfish and seaweed. What waste that can be processed into something more useful. Coastal soils are less fertile due to low organic matter and limited mineral and salt content due to this water exclusion. Because of that, our team created the project called as Alat Pembuat Pupuk Organik dari Limbah, Cangkang, Gonggong dengan Kontrol Otomatis. That accelerate fermentation in the fertilizer and fertilizer coastal soil that using EM4. Objective benefit. The objective from the project is develop a semi-automatic system to convert coastal waste as gonggong cells and seaweed into organic fertilizer. And second, improve soil fertile in coastal are using enriched fertilizer with EM4. The benefit is reduce environmental pollution from coastal waste. And second, produce value-added organic fertilizer for agriculture and reforestation. Mechanical design. This is our mechanical design and this is the power plant scale up, why the electrical of the PLTS or power plant. Next. This is the component the power plant is. This the component source is the power plant is 50 watt solar panel, MPPT charge controller, battery cable, and fuse for MCB DC, flyback diode, and voltage monitor. This is how the power plant system works. The energy flow, solar panel produce the DC electricity about the 17 to 18 volt. Open circuit drops to 30 to 50 volt when load. Enter the solar input terminal on the solar charge controller or SCC. Function to regulate charging to the battery to prevent overcharging or over discharging. The output from the battery is connected to plus and minus. Load output can be used directly for 12 volt DC like 12 volt battery receive charging from the SCC. Now I will return to the moderator.
Okay, we're back on our mechanical design. So I'm gonna explain a little bit of our design. So we can see here there is two boxes. This is for store our Gonggong shell and single shell. And this one is a mixer box. This one is our solar panel, our battery, and this is our wiring box. And our component that we're using in this project, number one is micro linear actuator. The function is to open and close the storage box when we want to put it into the mixer box. And the second one is HX711. The function is to convert load cell data to weight. And the third one is storage box. It has 7 kilogram steel. It is made from stainless steel. And the next is load cell. This is 0.10 kg. Next is I2C LCD. The function is to inform the amount of weight we have on each material. 6 and 7 is push button. The first push button is to select the configuration, rather it's 1 by 1 or 2 by 1. And the second push button is to determine the proportion of each material. The main component is ESP32 as a controller brain. Number 9 is emergency switch as a safety feature. Number 10 is TRE3 MNG as a mixer motor driver. And 11 gigabit 7.520 DC motor as a mixer motor. Number 12 mini motor pump as an automatic AM4 add-on while mixing. Number 13 buzzer as a sound notification when the mixing is done. For the frame that I'll be using in this project, basically from metal, but yeah, stainless steel and iron plate. Okay, this is our circuit design. This is our flow chart for the machine. So for the first step, we want to put the ingredient in the box. And next one is to calculate how much material in that box. And then we choose option 1 or option B. Rather we choose 1.2 ratio or 1.1, 1 by 1 ratio. And then after we choose, we put the ingredient into the mixer box. And then we're going to mix it for 20 minutes. While mixing it, we're going to add 100 milliliters of AM4 TRE3. And then after the mixing process is done, we're going to remove and store it in the cool place for 7 days. And after that, the electrolyzer is ready to use. again about the system in our machine. In general, this is a semi-automatic fertilizer making machine designed to process organic waste from Gonggong shell into fertilizer. The system operates using TRE3 to ensure that each step of the process runs in ordinary and automated manner after user input. There are three main components in the system. Container A and B basically just a box to contains our ingredient, and container C function as a mixing container. Okay, for the dosing system, the dosing system is controlled by ESP32 microcontroller, which regulates the amount of material dispensed based on predefined percentage. The material quantity is measured by a sensor. So, container A and container B store the raw material, and the load cell container a load cell with an HX711 module to monitor the remaining weight of the material, an automatic dispensing mechanism such as valve or auger controlled by microcontroller. The system allows precise material dosing. For example, when the microcontroller comments to dispense 1 kilogram of shell powder, the container will release the material until the measured weight is reduced by 1 kilogram. And the container C serves as the main mixing chamber where material from containers A, B are collected, and they're going to mix the ingredient in there. Okay, for the next thing that we're going to explain is simulation and our result. They're going to explain, that's going to be explained by Dary.
For our moderator, in the simulation, I use ESP32, our microcontroller, and load cell and module AN7011. So in our simulation, we use software copy we use load cell and LED to replace the Anggota and the mixer. But for load cell, in the workpiece simulation does not produce accurate swing. So this because the simulation cannot display real measurement data. In this simulation, there are two push buttons. Is pressed to Anggota LED turn on. After both buttons are finished, the mixer and the mixing pumps are on. And after that, another LED light and buzzer up as anything on, then the fertilizer is ready. For the time information, the timing will be adjusted to match the account simulation based on the required weight in grams or volume in meters. Oke, di sini ada selnya. Jadi untuk sensor load di simulasi waktu ini nggak bisa akurat. Jadi di sini pressure-nya itu kalau nggak salah bukan 15 kilo.
Sorry, fast.
The load cell not accurate for weight because the simulation cannot display real measurement data. And this user push the button, this button for User choose the push button 1 and 2. The push button 1, this 2 compression 1 and this 1 compression 1. User push the push button. Push the push button and I2C show the codec user choose and LED on the Anggota box 2 and box A LED. And next, yeah, user choose the push button compression 2 compression 1 or 1 compression 1. With the user choose the toggle or push button 1 or push button 2. This the LED on. This the mixer. This LED for the mixer on, and this the mini pump for PM for liquid. After finish two mixers, LED on the finish fertilizer and buzzer on. Okay, next.
Okay, so that's it for our presentation. Today.